instead of always just graphing it and making a right triangle. Because look at how big those numbers are. Do you want to have to make yourself a big old graph that goes all the way up to 30 and negative 15 and all that, and then count? I don't. I wouldn't want to. So friends, this is why you need to have that distance formula memorized, because you're going to need to use it for bigger numbers like this. Could you graph it and make a right triangle? Sure. But man, that would be doing the most. So let's see if you guys can remember how to break down that distance formula. So first, okay, so first we square. You go ahead and tell me. What do you think it is? Let's see if you got it. It's long. I don't know too many people that have it memorized yet. Let's see.
Like the actual okay, so the little square root symbol thingy.
Yes.
And then, x2 minus x1 squared.
Yes.
Plus y2 minus y1 squared.
Woo! Yay! Nice. Okay. So first you square parentheses. I know what you did was a lot less annoying than the song, right? All right. So you've basically got all it is a squared plus b squared equals c squared. It's just kind of hidden in there. All right. So if I start, and you guys, I sure would be a good idea for you to be filling this in with me. Okay. So my x2, okay, x2 is my second x coordinate, right? The first one is on the left. The second one is on the right. McKenna asked yesterday, and it was an excellent question, does it really matter which one you do first? And honest and truly, it doesn't, except for the fact that if you look in it, like you could have done negative 15 first, but most textbooks are going to say the second one minus the first one. So I'm just trying to get you used to seeing the way it's going to be written. So I'll substitute a 0 in for that x to the second, and then I need to subtract a x1. So I've got to subtract the x1s. Now I'm doing 0 minus a negative 15. What is going to happen when I subtract a 0 minus a negative 15? That's going to go ahead and turn into a plus. So I'm going to go ahead and turn that into the addition sign that it's getting ready to turn into. And then don't forget that you need to square it. Then I need to, so I subtracted those two x values. Now I need to subtract the two y values. So I've got to do 37. And I'm going to take away my y1. So that'll be minus 26. And again, I'm getting ready to square it in just a second. So 0 plus 15 is 15 squared. Do we know what 15 squared is? That's one of our perfect squares. 225. Yay, friends. All right. And then 37 minus 26 is 11. And if I square that, we better know that one too. 121. Okay, and I haven't been bringing down my square root symbol throughout all these steps. So just keep in mind that square root should be there as well. So in order to figure out the final distance, I need the square root of 346. And here lies the problem and why I wanted to specifically do another one of these with you. Because today, you're going to be finding the square root of bigger numbers, okay? Yesterday, you were allowed to just plug it into your calculator and just round it to the nearest tenth, whatever your calculator gave you. Here is the issue with that. In real life, when you are doing distances over large distances. So again, planes is one that always comes up to me because that's definitely probably the way they're used the most often is flight paths. If you round a mile to the nearest tenth, you could cause an accident. So you don't want to round because a tenth of a mile is a pretty big distance. So a lot of the time, you need to leave it as an exact answer, which means radical form. You got to simplify it because the computer understands that's an exact figure and that you haven't rounded it. So, I wouldn't know if 346, any of those perfect squares go into 346. I know y'all have better number sense than I did at your age, so maybe some of you guys already do. But for those of you that are like me and need some tips about how to break it down better, here's a way to do that. Okay, so you're going to see on Google Classroom, I gave you that list of things that are called divisibility rules. They're like, for lack of a better term, they're tricks to help you figure out when certain numbers go into other numbers. And so the first perfect square I might want to investigate would be 4. Let's see if I can factor a 4 out of 346, because that would be my first square root. Well, the divisibility rule for 4 is if it's a big number, you look at the last 2 digits, and if the last 2 digits make a number that's divisible by 4, then the whole number is divisible by 4. So let's look at the one we've got right here. 346. Does 46 divide by 4? No. 48 does, but 46 does not. So because those last 2 digits are not divisible by 4, that means that you cannot factor a perfect square of 4 out of there. So that also eliminates some other perfect squares. For example, 36, you know won't work. Because if 4 doesn't go into it, since 4 goes into 36, that means that 36 won't go into it either. So you can actually knock out, through process of elimination, some of the bigger perfect squares. Ooh, great question. So what else does that knock out? 16, thank you. 16 can't be a factor because 4 goes into 16, doesn't go in there either. So what might be the next logical one to try?
8.
You're close. What's the perfect 9? Right. So let's see if 9 works. So the trick for 9 is the same as the trick for 3. If you can add all the digits together, so right here, 1 plus 6 plus 2 plus 9, if you add it up, that adds up to 18. 18 is divisible by 9, so you know the whole number is divisible by 9. So let's see if that 9 trick works. What's 3 plus 4 plus 6? 13. Is 13 divisible by 9? No. So 9 won't work for that one either. So because 9 doesn't work, if we're thinking perfect squares, what's another perfect square that won't work? Because 81 won't work because 9 doesn't work. So if the smaller factor doesn't work, 81 doesn't either. Okay, so we've already kind of eliminated 25. First of all, it's got to be divisible, have a 0 or a 5 on the end for 5 to even go into it. So you know 25 won't work.
5 won't either.
Yeah, so we already ruled out 36. We should try 7 next because it could be 49. So the trick for 7s is a little goofy. Okay, for 7s, what you do is you take the last digit, whatever that might be, and you double it. So in this case, 2 times 2 is 4. And then you subtract it from the rest of the number. So that's kind of like a goofy trick that I don't know who the person is that discovered that. It's fascinating to me that they figured out a way to make that work. So let's look at what we've got here. So that means I would need to double the 6, which is 12. And I would need to take the rest of the number. What's 34 minus 12? 22. Is that divisible by 7? No. So since 7 doesn't work, that means what perfect square won't work?
49.
49 won't work. So this is why I'm giving you a lot of time to do this assignment. It's not the distance formula that's going to mess with you today. It's going to be figuring out how you could simplify it. 10 won't work because it obviously doesn't end in 0, right? So if 10 doesn't work, that means 100 won't work. And so on and so forth. So you go through that process. I'll go ahead and tell you, not a single perfect square goes into 346. Okay? So we did all this to prove that you can't simplify it any more than it already is. Yay! Why are you looking at me like you want to punch me in the face? So what you would literally type in for your solution is the square root of 346 because it actually can't simplify. So that's the reason I'm giving you guys lots of time to do this assignment.